Objects created in 3ds Max aren't typically designed to automatically bend or in any way change their shape if they happen to come under some form of stress. No, geometry, when animated, is purposely encoded to maintain a certain rigidity or stiffness. It's just the way that things have been programmed to work. No matter how light or flexible an object might be, unlike the real world, CG surfaces just aren't designed to show the same normal signs of being stretchy or pliable. When needing an object to appear instead soft and deformable, Max has a quick and easy solution. It comes in the form of a special modifier called Flex. This video will show you how it works. I'm using a file named Flex Modifier. You can find it in the Working Files folder. The scene simply consists of a pole, a stand, and a little extra weight that's been added to the top. All the surfaces have been attached together, so we're basically looking at a single object. To put the pole under a little stress test, I've animated it sliding across the screen into a couple of different positions. Those movements all taking place over a total of 75 frames. You can see that by selecting the object and scrubbing the timeline. Let's also play back the animation so we can get a little better idea of the speed of the movement. Now as things play back, you'll notice that the pole isn't exhibiting any kind of give or sway, even though that the box at the top of the pole has been designed to give it a little extra weight in that area. Let's see if we can't create a little more realistic bending action by adding the Flex modifier. With the pole selected, we'll enter the modifier list, adding a flex. Let's go ahead and play back our timeline again. Take a look at the difference that's made by simply adding the Flex modifier. When the pole races from one location to the other, you can now see a slight bending to its surface. When it reaches its destination and stops, you can also see a gradual swaying back and forth until it comes to a rest. That's all the result of the modifier we added, the Flex. Let's see if we can't make that little side-to-side wiggle we're getting a little more pronounced. In the parameters section under the modifier stack, our first setting is Flex. This sets the actual amount of flex and bend. The higher the number, the more stretch that'll be exhibited. Let's take the flex amount to 3 and we'll play things back again. With the higher value, you'll see that that's made a difference in the way things flex and bend. Let's also try a flex value of 5. Now the flexing action is even more noticeable. Below flex, you have strength. This controls the overall spring strength. Let's take the value to 5, we'll play it back and see how things look. Why don't we also see how things would react using a strength value of 2? And let's also experiment changing the strength value to 1. So the lower the number, the longer it takes for the flexing action to complete its movement. Let's take the strength back to its default value of 3. Now, there's also a setting that controls the length of time it takes to return to a resting position. It's the sway setting. The way it works is, the lower the sway value, the longer the flexing or bending action lasts. Let's try setting the control to 4 and see how things look. Let's also try a value of 2 for comparison. So the lower the number, the longer it takes for the flexing action to complete its movement. If you want the pole to stop quicker, we might try a value around 10. Let's see how that would look. Notice how that seems to stiffen things up. Let's also take the sway back to its default value. That was 7. Now, you can also change the location from where the flexing action originates. With the way things are set up right now, the pole appears to be flexing from its bottom. In other words, the back and forth movement is originating from the bottom of the object. Let's see if we can't change that to the top. Back at frame 0 on our timeline, we'll open up the Flex modifier. At the sub-object level, let's click on Center. This represents kind of like the flex's pivot point. The coloration that you now see on the object's vertices visually display just how much weight or level of influence that given vertex is receiving during the flexing action. Now controlling the center's location on the flex, Let's grab the blue or Z direction on our gizmo, pulling the center to the top of the object. Now this should radically change the way this thing flexes around. Let's go ahead and play things back so we can see the difference that the center's position has made. We're now seeing the flexing action completely change the way that things bend around. Let's see how things might react if positioning the center in the middle of the pole. Once things are in position, we can again return to playing back our timeline. So does the position of the flex's center make a difference in the way things bend around? You bet. Back at frame 0, let's return the center's location to the bottom of our pole. Once we've done that, we can click back at the top of the flex, getting out of sub-object mode. Okay, let's make a few changes to the numbers. We'll take the flex value to 6, strength we'll set at 1, and sway we'll put to 12. When entering your values, you can either use the down arrow or the tab key on your keyboard to move to the next field. Let's now play that back. So what do you think? You going to be able to find a few ways to put the flex to work? A car antenna swaying back and forth, maybe a tree branch getting pushed around in the wind. How about the floppy ears on a cartoon character swinging around as he turns his head from side to side? They'd all be perfect examples of using the flex modifier to add an extra level of control to your scene. Now that you know how it works, you're going to be finding all kinds of ways to put it to use. I'll go ahead and save the scene out as flex modifier completed if you'd like to look it over.